Today, we're going to create a toon shader lighting model. Let's go! Alright, so we're in the middle of a series of videos on making custom lighting models. Usually, when you use a node-based shader editor like Unity's Shader Graph or Unreal's Material Editor, you're able to control the base color, normal, smoothness, and metallic properties of the surface with the graph tools. But in this series, I'm showing you how to use the graph to actually calculate the lighting. The cool part is that with this technique, you can leave out features to make the lighting cheaper or change the lighting around to stylize the results. If you haven't seen the rest of the videos in this series yet, I'll leave a link down in the description so you can catch up. So today, we're going to stylize our lighting. Normally, lighting is smooth, like what you can see here. We're actually going to modify the lighting so that it looks like it's made from areas of different color paint. So let's get started. The first thing that we're going to do is take our lighting subgraph here and duplicate it so we can make a new toon shader version. So I'm going to grab our simple lighting subgraph. Oh, and by the way, I'm doing everything in Unity right now, but in a minute we're going to switch over to Unreal, and I'll show you how to do something similar in that engine as well. Okay, so I'm going to duplicate my simple lighting 2 lighting model, and instead of simple lighting, we're going to rename this to toon lighting. Then I'm going to grab my toon lighting, my new subgraph here, and we're just going to plug everything into that instead. So I'm going to plug my normals in. I'll set my metallic to 0, my smoothness to 0.4, and my ambient occlusion to 1. Great. So now we can replace our simple lighting with our toon lighting. Now, if I save this, obviously it's going to look exactly the same because it's just a copy right now. So let's jump into toon lighting and make a couple of changes. Here is our Lambert, our diffuse lighting subgraph, and we're going to duplicate that one. So here's our diffuse Lambert, and I'm just going to copy and paste it. And instead of diffuse Lambert, I'm going to call it diffuse half Lambert. Now, we've gone over half Lambert before in a previous video, but let's jump into this lighting model here, and I will show you what half Lambert is. So with regular diffuse, the lighting goes from pointed straight at the light source to halfway around so that it's right at the terminator. And from that point on, the lighting value is just 0. So our dot product is comparing or measuring the relationship between the light source and the surface normal. And if they're perpendicular, then the surface is lit. And if they're parallel, then the surface is 0. It's not receiving any light. And then around the backside, it's just completely black. But what we're going to do instead is I'm going to multiply our resulting lighting here by 0.5. And then we're going to add 0.5. And so instead of a range of 1 to -1, I've shifted the range so that it goes from 1 to 0 all the way around the model. So you can see in the previews here, this is my original lighting. It goes from 1 here to 0 here. And what we're doing is wrapping this lighting all the way around to the back side of the model here. Now, you can't tell very well in this preview, but it actually does go from 1 to 0 here on the back. And that's what's called half Lambert, because the lighting is wrapping all the way around to the back side of the model. So we're just going to add or multiply by 0.5 and then add 0.5. And we're going to fit these nodes right in here. And really, that's it. That's the only difference between half Lambert and Lambert. Just that, multiply by 5 and add 0.5. Okay, so let's switch back to our toon lighting subgraph. We'll grab our diffuse half Lambert and pull it in, And we're going to replace our diffuse Lambert here with our diffuse half Lambert. And I will save that. And now you can see our lighting looks a lot softer. So let's just go ahead and delete our half Lambert, and we'll bring in delete our Lambert, and we'll bring in our half Lambert. Okay, we need to do the same thing for our additional lights subgraph here. And so let's pick our additional lights subgraph. I'll copy and paste it, and I'm going to call this additional lights half Lambert. And we'll open this up, and we need to do the exact same thing here. We need to change the code that we've created to multiply our diffuse by 0.5 and then add 0.5. So I'm just going to scroll down here in our code till we come to the place where we're calculating the n.l, the dot product between the normal and the light vector. So here is our dot product between the normal and the light vector. And just right here, we need to multiply by 0.5, and then we need to add 0.5. And that's going to give us our half Lambert. So now we can save our new half Lambert additional lights, and we'll switch back to our toon lighting. And now we need to replace our additional lights subgraph with our half Lambert version of it. So I'm just going to wire this in. And I'm just connecting up all of the same wires that we had before, so nothing special happening here. And then I'm just going to connect this up as it was as well. And then I'll get rid of the previous additional lights, and I'm just going to replace it with the new half Lambert additional light. So we'll save this, and it updates over here. Okay, so we've created our half Lambert. We've got our lighting wrapping all the way around the back side of the model. And the next thing that we need to do is we need to add our diffuse lighting together. So instead of this combination that we've got down here, I'm going to create a new area of our shader up here, and we're going to replace this lighting with our new lighting. So I'm going to take the diffuse that's coming out of our additional lights half Lambert, and I'm going to multiply it by the light color. And then I'm going to add our ambient in here. And what we're doing is setting up some lighting to get ready to posterize it. And I'll show you what I mean in a minute. So here is our diffuse lighting added together with our ambient lighting. And I'm just going to add a saturate node here just so that we can make sure that our lighting doesn't get above 1. And now we need to desaturate this, or take the color out of it. You can see here that these are vector 3 input and output ports. And we need to use the saturation node to take the color out of this, because what I'm doing here is I'm making a mask that determines where the surface is lit and where it's not. So I'm just going to desaturate this to make sure there isn't any color. And then we're just going to take the X component. So I'm going to use a swizzle here and grab our X, so that now we're down to just a single channel. It's a single black and white channel that determines what the brightness of the lighting is. And so now what I can do is use a posterize node, and the posterize node will take our lighting gradient that we've got here and chop it up into distinct regions. Right now, our lighting is nice and smooth. It goes from 1 on the lit side to 0 on the not lit side, and it's this nice smooth gradient that wraps around. But we want to convert this to our toon paint. And so I'm going to plug this into a posterize node, and we're going to set the steps to 3. And now you're starting to see something that looks like toon lighting. We've got the lit side here, and then kind of a medium here, and then the dark side here. So this posterize result is what we're going to use as our mask to create the areas of toon shaded paint. And what are we going to do with this mask? Well, we need to take the base color of the surface, and we need to use the mask to blend between the regular base color and an alternate version of the base color that is darker and more saturated. So I'm going to come over here and grab our saturation node and copy it, and we'll plug the base color into that. And whatever this base color is, we're going to increase the saturation by 1.6. And so basically what we're doing is the paint that we're creating for this toon shader is going to be darker and more saturated on the dark side of the model. So here is my base color. I'm saturating it, and then I'm going to add a multiply here, and we're going to multiply this color by 0.1. So this is a dark version of the paint. All right, so we've increased the saturation and multiplied it by 0.1 to darken it. And now I can add a lerp node here so that we can blend between the dark version of the base color and the regular version using this posterized toon shader mask. So now whatever the base color is, we're going to have the base color itself on the lit side, and a darker and more saturated version of the base color on the shadow side. Okay, so that is our lighting model. And then the last thing that we need to do is just make sure that we're accounting for our specular as well. So I'm going to come back over here to our specular, and we're going to multiply specular by the light color, and then we'll just add it in at the end. So there's our specular highlight. And we'll bring it over here to the rest of our lighting model and just add it in here at the end. Okay, so there is our toon shader paint with our specular added in. And then we can just wire this into our output. We're just going to ignore fog for now. I'm just going to assume that since this is a toon shader, you don't want fog. But if you do, you can just add it in at the end as well. Okay, so now we can remove these other nodes here that we had from the previous lighting model and use our toon shader lighting model instead. And I'll save the final result here. And now you can see on our nice lion statue that we've got some really beautiful toon shaded paint going on. Wherever the model is in shade, we have a darker and more saturated version of the lion's color. And wherever it's in light, we just have the regular color that we've got there. So that's really cool. We've got this nice toon shader going on where we've been able to take the lighting model and alter it so that we're posterizing that lighting. And we can control this a little bit. Like if we only want to have one bright and one dark region, we can just posterize this to 2, for example. And now we've got just 2 regions. Or if we want to really crank this up, we could make more complex toon shading by increasing the number of regions. And you can see here we've got a whole bunch of steps going on. And so we've got kind of really complex looking toon shading, but we're able to control that just by switching the number of steps in our toon shader. All right, that's it for Unity. Let's switch over to Unreal and I'll show you how to do something similar in that engine. Okay, here we are in Unreal, and we're going to do the same thing here in Unreal that we just did in Unity with a couple of key differences, and I'll show you those as we go along. So here is our lighting model that we've set up in a previous video. And the first thing that we need to do is clone our lighting model and make a toon version of it. So I'm going to grab our simple lighting 2 material function, and we'll copy it, and I'm just going to rename it, and we'll call it toon lighting. And so instead of simple lighting, I'll drag toon lighting in, and we'll just wire it up the same that we had our toon lighting wired up before. So we're going to connect up our roughness and our normal and our ambient occlusion, and then plug that into our root here. And we'll delete the old one, and now what we have left is our toon lighting. So let's save this, and then we'll jump into toon lighting and make the changes that are needed there. Okay, so here in toon lighting, you can see that we've broken things down into individual material functions. So we have our specular here, our Lambert here, our ambient here, and then everything gets added together and integrated, and then we output the lighting result. And so the first thing that we need to do is, instead of using diffuse Lambert, we need to use diffuse half Lambert. So we need to make a copy of diffuse Lambert. So let's come here to our diffuse color. There's our diffuse Lambert. We'll copy that and paste it. And I'm going to rename this to diffuse half Lambert. And just like I said a minute ago, half Lambert is a version of diffuse lighting where we make the lighting wrap all the way around the model. So where the lighting is coming straight at the model, we have a value of 1. And normally, we would have a value of -1 around here in the back, because that's what our dot product node is doing. And then we use the saturate node to clamp it between 0 and 1. So it goes from 0 here, it goes from 1 here where the lighting is hitting it directly. And then it gets to 0 right here. This is called the terminator. It's like halfway in between the front and the back. And then where it would normally be -1 here, because we've got this saturate node in here, we prevent it from going to -1. So it's just 0 from the terminator all the way around to the back side. But with half Lambert, what we're doing here is adding in multiply by 0.5 and add by 0.5. And if we wire this in, the result is that our lighting wraps all the way around the model. So instead of going black at the terminator, now we've got it going black all the way around the back side. So that is the difference between Lambert and half Lambert. It's just this simple multiply by 0.5 and add by 0.5 and add 0.5. So we've got our half Lambert lighting there. And we'll save this and switch to our toon lighting here. And instead of our diffuse Lambert, we're going to replace that with diffuse half Lambert. So let's wire in our normal and then connect up our diffuse Lambert here and here. And then we can get rid of that diffuse Lambert and keep our diffuse half Lambert. All right, now in Unity, we were able to support multiple light sources, but I'm not able to do that here in Unreal just because the engine doesn't expose that amount of flexibility. I'm not able to write my own shader code and just kind of inject it and have it account for multiple light sources. So generally, if you want to do that sort of thing, you either need to alter the engine source code, which I don't really want to go into today, or you need to do all of this as a post process. And there's a really great tutorial, another video on LinkedIn, not one of mine, but a video that I really like, and I'll link it down in the description, that shows how to create a toon shader as a post process. So if you want to go that route, check the description. Okay, so now we just need to alter how all of our lighting is getting put together so that we can create toon lighting instead of nice, smooth, realistic looking lighting like what we have now. Okay, so I'm going to take the result of our half Lambert and I'm going to multiply it by our light color. And then I'm going to add our ambient lighting as well. So here is our diffuse lighting multiplied by the light color. I'll grab our ambient lighting and add that in. And then we're going to use a saturate node to make sure that we don't go outside of the 0 to 1 range. Okay, so this lighting right here could have color in it. And so I want to desaturate the color so that we narrow it down to just a single channel. And so I'm going to use the desaturation node. I'll plug our lighting into that. Then I need to add a vector 3 here and set it to 0. So this desaturation node, I can tell it how to desaturate it, and I'm going to desaturate each of the channels. So whereas before we had color, and now actually needed to set each of these to 1 to desaturate. And now that I have each of the 3 channels set to 1, we get a black and white or a grayscale result. Okay, now that I've converted this colored lighting into black and white lighting, I can just add a component mask and take just the first component so that we're just dealing with a single channel now. The reason that we're dealing with a single channel here is because we want to create a mask. And we're creating a paint mask that shows us areas of brightly lit paint and other areas of dark paint. Okay, and the next thing that I'm going to do is add a posterize node. And the posterize node is something that we covered in a previous series of videos. And so I'm going to add this node and connect it up. And then I'll just briefly jump into it and show you how it's made. So we're going to add the posterize node, and I'm going to give it a step count of 3. And so we've broken our paint regions into 3 different areas, kind of a bright, a medium, and a dark region. So let's just quickly jump into posterize, and I'll show you how this works. So we take the input value, and then we multiply that by the number of steps, and then we floor the result, and then we divide it again by the number of steps. And basically what we're doing is taking a smooth gradient and converting it into kind of a chunky gradient based on the number of steps that we've decided that we need. So if we change our number of steps here, I can make this 8. And now you can see I've got 8 steps in my gradient. I think we had it defaulted to 4, so we'll go back to that. But that is how the posterize material function works. I'll link down in the description. There's a video that I covered like quite a while back where I showed how to make that posterize node. Okay, but that's what we do with our toon lighting. We're basically creating this, we're taking this smooth gradient of the lighting here and posterizing it so that we chop it up into discrete regions. And what are we going to use those regions for? Well, what we want to do is take our base color that we're bringing in over here, and in the bright region, we're going to use the base color as it is. But in the dark region, we're going to go for a more, like a darker and more saturated colored version of the base color. And so we need to go ahead and create that. So I'm going to grab my base color here, and we're going to add the desaturate node again. But instead of desaturate, this time we're going to use the desaturate node to saturate the color. And I know this is going to sound kind of counterintuitive, but I'm going to give my 3 channels a -1 value, and we can plug this into fraction. And when we give negative values to our desaturate node, instead of desaturating, it's actually saturating. it's making the result brighter. So now we can take the saturated version of our base color and darken it down. So we're just going to multiply it by 0.1 to make it darker. And then we can add a lerp. So there's our linear interpolate node. So we're going to lerp between the more saturated and dark version of the color and the regular version of the base color. And as our lerp mask, we're going to use our posterized lighting that we created over here. So here's our posterized lighting. We'll plug that in as our lerp. And now let's just grab our result that we've created so far and plug it into our output and take a look at what we've got. Okay, so you can see that we've got a couple of discrete paint regions here. We've got a bright region, a medium region, then we come over here and we've got the dark region. So our toon shading is coming together really nicely. And I'm just going to set, I really prefer a field of view of 50 instead of 90 here, even though it defaults to 90. 50 just works better for me. Okay, so there's our toon shading. And the last thing that we need to do is bring in our specular. And so if we come over here, we've got our specular blend result there. And I'm just going to take that result and multiply it by the light color. So here's our light color. And then I'll bring it up here and add it to the result that we've created so far. We just want to make sure that our specular lighting is also accounted for. And then we'll wire it out to our lit. And we'll save that. Now we've got a really nice looking toon shader. And I'm just going to clean things up a little bit by deleting nodes that we're not using. So we're not using any of these. Yeah, there we go. All right, so again, just to kind of sum up, we've taken our lighting and we use that desaturate and posterize node to split it up into discrete steps. And then we use those steps as a mask to blend between a darker, more saturated version of our color and our regular color. And then we added in our specular multiplied by our light color. And that's our final result. So if we save this and switch back to our scene, now you can see our lighting is nicely posterized. It doesn't really look that great with a normal map here because the normal map is really bumpy. So I probably want to go back in and kind of tone that down a little bit. But we end up with a really nice toon shader with some cool looking discrete paint regions. All right. So that's it for this week. I think for next week, I'm going to show you how to create kind of like a film noir stylized lighting model. So be sure to come back next week for that. And in the meantime, have a great week, everybody. Thanks for watching.